Okay, so welcome to a new episode of Soundwaves with Sonodyne. And I'm joined here with Ken Chan from the Offshore Renewable Energy Catapult. And we're going to talk about robotics in offshore wind. Ken, first of all, would you like to just introduce yourself and a few words about what you do at the
Yeah, great. Thanks for having me. I'm Ken. I'm the Robotic Operations Lead in ORE Catapult. I've joined the business for about 5 years now and working through technical developments and into business development, mainly around robotics. And the role for me is to look at robotic development in terms of asset development, the industry requirement for testing, and what is the upcoming technologies and what we need to do to cater some of these innovations, trends that is going forwards.
Yeah, I understand you're working with a fair few developer type stakeholders at the Catapult to have a keen interest in what you're doing and advancing the industry, which sort of brings me nicely into my next question is robotics in offshore wind at the moment. Offshore, which I think it's acknowledged that offshore wind is going through a little bit of a tumultuous time. You know, it's a little bit of a market slowdown with no projects have been cancelled. Hornsea, most notable of recently. What's your feeling on the adoption of robotics right now in the sector,
Yeah,
given the current climate?
no, I fully appreciate that. We're not at the most exciting times, but I think in terms of robotic innovations, it is still very strong. The adoption rate is certainly an issue, um, both from a de-risking and market confident, competent, um, and some of the operational costs is a big challenge for the industry. However, I feel the adoption of robotics is necessary, and it will definitely come through in the coming years. So really, my feel is that the percentage of adoptions for robotic technologies, is still low. However, the pipeline of opportunity is exponential. The idea well in terms of what we can adapt and all the
Scales,
things
doesn't it?
is massive. Yeah.
What do you think the main barriers are for robotics in renewables? I mean, Sonodyne, we've used robotic systems in other sectors, particularly oil and gas. You know, especially deep water ROV and all that type of work.
Yeah, sure.
Frontier development. But what do you see are the main barriers? Because ROVs are used quite frequently.
Yeah,
and
no,
we've got a good customer base, ROV operators.
Yeah, so I think I can probably summarize it in maybe 2 or 3 areas. I think one main area is the understanding of technologies, the level of autonomies of robotics. People think, oh, I've got an AUV, but what classification it is. I think some of this development and standards really coming through, and a lot of people realize actually what was autonomous robotics is not really that clever in that sense. So I think it's understanding of what the technology innovations can achieve. But moreover, I think it's part to also to do with the existing deployments and technologies, and the platform for that to incorporate robotics is somewhat set in stone on some of the existing
Yeah.
deployments.
Yeah, I tend to think that the sector developers, I don't know if trust is the right word, but I'll sort of use it. If you know, there is a trust with
Yeah.
levels of autonomy. We're seeing it come through, likes of Exocean, Fugro,
Yeah.
and their USV systems. I know they tested the Catapult as well, the Fugro USV to
Yeah.
ROV deployment.
Yeah.
But again, I think there's an element of the trust of a technology, and ultimately because that's the adoption it does seem to be probably quite slow, that then the cost benefit realization hasn't properly come through.
No.
And you're sort of relying on Fugro and Exocean to sort of lead that right on a USV.
Yeah.
I mean, we'll get onto AUV in a second, but yeah.
Yeah, so you're right. I think because of the market share of robotics company are in the lower percentage, which means that as much as they adopt a lot of the operators, the existing strategies on planning for O&M especially, is already been cast into somewhat vessels deployment, existing contracting, which means that it's actually cost them more to adopt this technology and not quite less. But I think the trend for robotics is as the industry developed, the percentage of utilization of robotic technologies are more commonly understood and adopt. That momentum will then really shift from an add-on to really a good proportion. That's when, in my opinion, that's when the real savings occur, because you can really downsize crew, you can really put people away from an offshore dangerous environment.
Carbon emissions.
Exactly. At the moment, the percentage of robotic operations is still very small and a bit of a trial state, and it is also down to do with trusting the technologies. And from offshore renewable catapult point of view, we are tackling that trust issues as a technology accelerator, and the role that Catapult sort of stands in the industry. Our role is actually to de-risk technology, to give the industry market confident and competent in terms of technology delivery and how safe and how quick, and really validate some of these innovations for the operators to say, yeah, actually, this technology has been through these rigorous testing, validations, and confirmations, and this technology
getting that
now
stamp of
ready.
approval and then create the trust through that process. Yeah, that makes a lot of sense, which sort of brings me on to like the next question. I was going to talk, because it came up yesterday in the robotics workshop, about test facilities, and we understand that you've got test facilities at scale. We've done demonstrations in the test tanks along with our sister company, Supervised Autonomy, demonstrating what our persistent sprint INS positioning system, navigation system can do, and that was excellent. But that was it was an enclosed environment, but ultimately we need test facilities that go further offshore.
Absolutely.
And so how do you see that for renewables, and like with the Catapult and also the wider sector, what's being done there around test facilities?
No, it is absolutely the critical path of our trajectory in terms of developing something offshore. We have a lot of collaborations with existing wind farms, but with an operational wind farm, the dynamic of offering testing capability of demonstrations are quite difficult.
Yes, because it's operating.
Because it's operating, some of the risk, the risk appetite will be a lot less than actually just trying somewhere offshore. So we understand, to enhance and develop robotics innovations, we need a bit of a play area, an area that if something goes slightly wrong or need tweaking, is not tens of thousands of pounds that will actually come back tomorrow, and 50 grand later you're not really improved. So really we're looking at an area that is run by the Catapult, who we have the autonomy to do what we see from an innovation standpoint of developing.
And that's interesting. Who do you think, and obviously you're overseeing that, and you're pulling through supply chain innovators, but also you're taking into account developer needs. But where do you see the real drive? Is it coming from the innovation, the research, universities, the current? We spoke to Paul Davidson yesterday, SMD, and they've got the new EROVs and talking about grander things there in terms of autonomy. But where do you see the sort of main thrust of autonomy and robotics and autonomy coming through industry? Is it being developer pulled and into that sort of test facility? So
it's a tricky one. I think in the robotic world, it is, because it's fragmented, might not be the right word, but there's a lot of different development going in parallel. Ultimately, safety drives some of the innovations. Ultimately, costs and deliverable and what the machine could do, and reduce humans going offshore. is one of the big driver.
Yeah.
Obviously, cost, lead time is playing part of the factors. So in terms of innovations, drivers, operators is constantly looking what is the new thing. But one of the analogy that I like to use is that currently everybody's backing every horse
Yeah.
in the industry and waiting until that one or two to succeed. Then the market might trend toward this type of, the utopia. It will be USB-C adapter for all. But at the minute we've got 20 different adapters and trying to service and new innovations there.
Yeah. And then when you're saying those, try that spread of technologies, where do you think, what applications they were ripe to autonomy? Where do you see that coming through? And ultimately, your test site will drive. So we're talking.
Yeah.
We spoke before about the Fugro USV ROV inspection. We've ourselves demonstrated or autonomous inspection to a degree. We call it supervised, but it sounds conflicting. But yeah, it's hands-off piloting, which then you start to see, well, that's where remote operations come in. So you still could use a full vessel. But yeah, where do you see, sorry?
Yeah, no, I think you're right. I mean, there are certainly a lot of steps from ROV operating machines to completely autonomous deployments and operating machine for AUVs. And there's all the things in between, whether there is supervised autonomies, semi-autonomies, and
the automotive.
So I think there's certainly iteration to get there. In terms of applications, I think AU inspections is obviously the most easily applied area. In terms of AUV, USVs, residency is obviously one of the biggest topics.
It's an interesting point. Do you see residency as
I think there's a big scope.
a true scenario there?
I think there's a big scope. I think the challenge of that is actually commitment to one machine or types or infrastructures. So where the USB-C analogy comes in, and if all the residency, all the power, all the comms are talking on the same language, then it opens a lot more doors for the operator to adopt a residency vehicle, because they're not tied into one or two supplier of a specific machines, and that's very high risk for them. In terms of maintenance, operations.
But ultimately, you want a RAMS, a risk assessment methodology statement that covers one type of operation, don't you?
Exactly.
And I think when we talk about residency now, we know residency is sort of underway in oil and gas, particular, sort of deeper water projects where you've got AUV or a 6 degrees of freedom hovering hybrid AUV doing its thing on the seabed docking station. But then I think about the shallow water aspect with fixed bottom wind in particular. And then it sort of makes sense to have, when we talk residency, maybe it is a USB type ROV configuration. But I think with floating wind potentially offers that. But yeah, what's your thoughts on that? What's your idea of a resident system at this moment in time?
Yeah, I sort of think about the application is more than actually what type of residency is suitable. Because I think as the wind farm go deeper, go further, some of the losses in energies is more than enough to service and sustain some of the residency robotics. So it makes more sense actually. Some of the floating wind, some of the further afield, fixed bottom.
You mean because so for deeper you go, the capacity is increased, the power generation capacity is increased, so it covers justifies the cost.
Exactly. By the time the energy which saw the percentage decrease of the losses, actually more than powers some of this stuff. And when we then look at sort of subsea station that is located, and that could be integrations of residency, location stations that's already happening on some of the supply chain. So I think as we grow deeper, as we develop those areas, I think the residency is more and more likely. But it is adoptions. it is adoption. It is all to do with how much new things do I have to buy to do this new thing when I have things that's working. And it is about the appetite of risk and also cost.
Yeah, and I think it'd be fair to say is certain developers who work across markets who probably are thinking about oil and gas and how they can transfer technology. So you could see that it come through that way as well.
Absolutely.
I think with floating wind, we know it's still going. Demonstrators are in the water, but it is taking a bit longer than we anticipated, or we expected to a couple of years ago for obvious reasons, but we don't need to go there.
I mean, going back in terms of the offshore demonstration zone, in terms of our roadmap to development, I think really what we want to do in the next 12 to 24 months is to establish robotics in the UK. You know, what is the industry needs? What are the developers? And how do the Catapult create a better linkage from technology developer to operators who ultimately will be using this? So rather than, and we briefly discussed it in the workshop yesterday, rather than the service provider looking at what equipment they will be buying, is actually the owner and operators look at how do they get the best value of what the inspection.
Yeah, but I mean, somebody explicitly said in the workshop that the developers could be not operating, but could have almost a real-time engagement with the robotic service provider.
Yeah.
So they're actually saying, oh, can you go and look at anode on turbine 10? Can you go and have a look at the scour around, and almost getting that feedback, and being a surveyor, having a survey background myself, I understand that pain of the customer, that ultimately they want to see the data as quick as possible, because that gives them, one, it spots problems, but also optimizes their own operations. But yeah, you need to understand your problems as soon as possible to reach efficiency in any organization.
And I think it's also then equally important for the operators and the owners to actually understand these new innovations. Because if they don't understand the innovation, what they could actually offer, they wouldn't want to adopt it, because it's actually something that I don't understand or not understand fully, and some of the risks associated with it, then that will put them off.
It's just that realization, isn't it? And I think, I mean, sort of like referring to some of the things that Sonodyne do, that's where your position, understanding where the robot, understanding where it is, whether it's a hybrid AUV, an ROV, or a USV on the surface, it knows where it is in the real world to provide you better, more granular or high resolution data, more accurate data, and also how that information is communicated as well. Again, Sonodyne, we provide through water communication, ultimately sending that through using either acoustics or you can use light wave, bigger data packages. But what I'm trying to say is, we can see a future where the operator can see maybe a tetherless vehicle, but images transferred from the seabed or subseas to the operators and the developers desk in near real time. And that's
and I think data, the quality of data, the speed of data, quantity of data is certainly a driver for enhancing robotics deployments in the offshore wind. It's those things that builds confidence. So actually, this is as good as sending somebody out and making a visual interpretation from an ROV point of view, or diver, or other things. But there's still areas in cross applications, from oil and gas, maybe from defense, to into offshore wind.
There's a lot of overlap.
And as the industry of offshore wind, we are relatively new compared to oil and gas, compared to defense. But a lot of these applications or development, it is shared across all these areas. So it is important to understand what makes them adopt some of these autonomous vehicle in other sectors. that enables us maybe have the attitude to accept and adopt these technology development for offshore wind.
I think personally, I've got oil and gas background, and I think the model, the oil and gas high risk, high reward. That helps, and I think this is more price sensitive market. So whereas a will, or sorry, there is a will. There is a will. It's just that is that will strong enough to overcome the risk of changing modus operandi? Because it's like, we know what we're doing. We've outlined all the project finance. We know what cash flows we should get down the line. And I think that's and you hit the nail on the head before when you spoke about that. Actually, it's not as simple as just going and testing it, right? But there's actually a significant cost associated with that, that testing, and it's like I said, it's quite price sensitive market. So that's that's a struggle as well. Just one of the sort of questions I wanted to end on, because I think this has been great. But was the use of AI. So we're seeing it going through a step change, obviously, society generally, globally. Artificial intelligence. How do you think the linkage between I and I, broadly speaking, how do you think it's going to change what the sector does and what you do as well?
Yes, sure. AI is new, but it's not new because it is new because it is new technology types, but it is not new because we're so familiar with it from the use of day-to-day applications. And I think in terms of the influence of what we probably understand AI from a day-to-day point of view, it helps with the adoption of AI. And I think there is definitely a role to play in AI, like robotics, like innovations. It is about the confidence. It is about understanding and reducing the risk and the potential implications of those. But I feel personally, in terms of AI integration into technologies, it could outpace some of the other robotic developments because of the potential background understanding of AI or day-to-day application that will enable some of the decision makers. Actually, I think this will work better than others. But certainly AI is...
You spoke yesterday though about using it for simulation. So at the Catapult, you've got your the data center, which is an enclosed environment, dry docks, converted dry docks, benign testing. So it's great for again, referring back to our great autonomy demonstration was done to industry. But then, obviously, the next step is going offshore. But you spoke about that preemptive step of using AI, a lot of simulation-based AI to test, your robotic system even before it gets into the water. Is there anything you'd like to sort of build?
So one of the program that we're developing is the virtual day, if you like, or the virtual environments where we apply real physics engines within these virtual environment with actual scanned data and with met-ocean data that is already exists. So the condition is real. The simulation is as close to real world conditions.
Well, you could have real world sensing feeding in, so on your test site, we've spoken about current profiling and that sort of stuff from a MetMast.
And this is where we were talking about in terms of more data. When we talked about more data, like real data, live data applications. And we feel that actually these simulations and virtual reality, before you go offshore, have a go at in the applications of the virtual engines, will build confidence. We'll build confidence actually what are the potential issue that we face and how does it reflect in the model simulations, and how does it work in terms of operations, autonomous decisions being made in this virtual engine. How does that differ? It differs if you apply different constraints and environmental changes to it. Then you can actually do more iteration before you go out.
So I think if we do full circle now, we've sort of speaking about industry, where we are at the moment, the challenge is around current environment, but ultimately we need the developers, the people who are operating these wind farms to adopt it. And and I think what you're saying there is really, we need that level of understanding right at the start of that process when you've got new systems, the testing, and they can walk through it almost like they're on that journey and that's how we build the confidence and trust to the sector.
Yeah. I think one of the most common things that I day to day when I speak to developers is they will all say, well, I've got technologies that I just want to demonstrate to the customer that it works.
Yeah.
And I'm looking at them and say, oh, what about these steps in between? It's like, oh, we haven't done them. Well, okay, well, for the operator to adopt technologies, they just don't, I like the look of this, I'll get this.
Yeah.
It's almost like you have to really put in the effort and to go into the granular details, say, I have tackled this with this, and this is the validation, this is the outcome, and this is the proof that we have done it. And I see certainly from a robotic innovations point of view for the Catapult, we stand in that critical role of elevating industry across the technology development to operators, to owners, and to the wider community. This is the next technology that has legs, and this will really change.
Yeah.
Then they can think about, okay, all of these changes eventually will collectively have a bigger cost-saving impact. And that's when they adopt the technology for...
It's about reducing the risk profile of technologies in an industry that's already risk averse, particularly because of the price.
Yeah.
But yeah, I mean, thanks, Ken. I think, yeah, that brings us nicely to the end of the podcast. I think any viewers, listeners, please visit us at sounderdine.com. But yeah, to any viewers, please go and visit Catapult's website too. But yeah, thanks for your time.
Thank you very much.
It's been great. And it's, enjoy the rest of the event.
Yeah, thank
Cheers,
you.
Ken.
Thank you. Cheers.
Yeah, thanks.